welcome to our first section of topic 10. Hopefully you guys are moving along well through topic 9, and this is one of our last two topics of the year. So we have topic 10 and topic 11. This whole topic is over circles. We're actually going to break it up into two parts. This is the first part. The first part here today is going to be going over some basic vocab and specific types of angles and arcs. This is kind of like the prerequisite for the whole unit. So you need to make sure you're comfortable with today's material. That will only make the rest of the unit go more smooth for you, or the transition will be easier. So if you will, obviously remember to pause the video at certain points if you need more time to write or draw diagrams. We're going to cover a lot of vocab, so just make sure you're writing those down. You can kind of shorthand, but you need to know those big keywords. Also, we're going to be drawing some circles today, so if you have a circular object, maybe like a roll of tape or a lid to a container or something that you can use to easily trace circles on your paper, might be something beneficial for you. And also a straight edge will be convenient for you today. All right, so let's get started. The definition of a circle. A circle is simply just a set of points that lie at the same distance or equidistant from a given point, which would be the center. So if you look over here onto this diagram here, we have point A can be rotated around the center point C, and if we were to place a dot at every single location that point A was moving around center point C, that would then make a circle. Okay, the circle or the outer line part of that circle is also known as the circumference, the distance around. C is the center point. When naming a circle, we name them by the center point. And just like everything in geometry, we have a symbol for a circle. So over here now, on examples 1 and 2 and 3, we're going to look at how to name these circles. We name it by the center. We don't care about the points that are on the circumference. So this first one, we would call it circle L. Now, your symbol for a circle is literally a circle with a dot in the middle. That's all it is. So number 2, this would be circle S. And then number 3, this would be circle R. So if you're asked to name a circle, this would be the notation that you would use. Let's go ahead and draw this on our paper. So if you need to pause the video for a second, you can. You're going to want to use your either a compass or the item that you picked from your house to trace your nice circle, and then go ahead and use your straight edge to draw these lines. Make sure you're marking in detail where the center of the circle is with that black dot there, and specifically that the orange line is going through the center, the green line is not. The red line goes from the center to the edge. That purple line touches the circle only once, and that blue line goes all the way through the circle, touching both sides of the circle, or touching the circle at 2 points. Our first vocab word here should be a familiar one, circumference. The circumference of a circle is just the distance around. It's almost like the perimeter of a polygon. For those of you who are familiar, these are our circumference formulas, but that distance around the circle is represented by 2 times pi times r, or pi times diameter. The second thing here, these should be pretty familiar, but radius and diameter. Your radius, or radii would be plural, starts from the center, travels out to the edge of the circle. Notice a radius is a segment. So when we name these things, we are going to name it with segment notation. Your diameter is part of a line or a line segment that goes through the circle, okay? And it has to go through the center. So your diameter is going to touch the circle at 2 points, and it must go through the center. That is like super big, that this point has to lie on a line segment in order for it to be the diameter if it touches both sides of the circle. I'm sorry, going back, one more thing here. The radius and the diameter are related. In fact, that the diameter is equal to 2 times the length of the radius. So just understand that if you want to find the radius using the diameter, you multiply it by 2, and then to go backwards, obviously your radius will be the diameter divided by 2. Next we have something called a chord. This is a little bit new for you probably, but it's just another line segment that goes through the circle, and it has endpoints on the circle, but this time our chord does not have to go through the center point. It does not have to. A chord that goes through the center point is then called the diameter. That's like a special chord. So a diameter is a chord, but a chord is not necessarily a diameter. So make sure you understand the difference there. Also on your drawing, go ahead and label the secant. It is a line Notice this time it's a line continuously traveling through with no end. So notice that it has arrows on the end of it. So we will use line notation when naming that. And intersects the circle twice. So here are the 2 points where it intersects the circle, but it is a secant because it is traveling through the circle and it is a line extending. A chord is a part of a secant that is contained within the circle. So this chord that we drew up here, the green line, if I was to extend it out, I could make it a line, which would then be a secant. But this piece right here that's inside the circle, that is the chord, and if we extend it out and actually make it a line instead of a line segment, then we call it a secant. Last but not least on our diagram, it is a tangent line. We just did trig, so you guys have heard the word tangent. If you guys can think about sometimes when you're in class and you start asking me random questions, you get me to kind of go off on a tangent. I kind of remember tangent that way. So if you're thinking about tangent, the tangent touches the circle at one point. So this would be kind of like our on-topic discussion. And then the longer you guys talk and ask me random questions, I kind of go off in one direction or off in the other, and I'm off on a tangent. This is a line that touches the circle exactly once. If it touches more, it's called a secant. So exactly once would be our tangent line. And the biggest idea here, you need to understand that the tangent line is always, always, always perpendicular to the radius. 100%. It's going to be a big, big idea as we travel through the rest of the parts of this topic. So let's go ahead. You guys can go ahead and pause your video and practice. I want you to name the following items. So using notation, using segment notation, line notation, the new form for circle notation that you just learned, go ahead and take a moment and answer these questions. Go ahead and check your work. So for these examples, you're going to use this diagram over here. If we're naming the circle, we care about the center point. So our center point here is O. So we would use our circle for number 1 notation, the circle with the dot, and then the letter O. List 2 radii, you could have had any of these options here. Your radii could be like something that goes from the center out, out, out this way, and this line right here is a radii. We just don't know what that point is, so we can leave that one off. A chord, so this would be your chord, DE, that would probably be the most common answer, but you could have also given me CE. CE is still a chord, even though it goes through the center, and would be also called the diameter. So make sure you have those answers for 1 through 4. For number 2, obviously any of those answers work, as long as you had 2 of them. True and false. CE is a chord. Segment CE is a chord because it touches the circle twice. It's also the diameter. So just know this is also the diameter. But remember, a diameter is simply a chord that goes through the center. Number 6, AC is a secant. That is false because AC does not touch the circle twice. It only touches it once. And it's not a continuous line. So that one is completely false. Number 7, there are 4 radii drawn on the circle. That is also false because we might have 1, 2, 3, and 4. We also have this guy. Notice I marked them all congruent. That is true. All radii are congruent. This would be the 5th radii right here. Even though it's not marked, we don't have this given point down here, it's still a radii. Moving forward, let's talk about specific angles and specific arcs within our circle. So an angle, obviously recalled, okay, from previous topics, it is just simply 2 line segments that are formed together, and the line segments can be called the sides of the angles. And make sure you are comfortable with naming your angle by using 3 points. And notice that A is in the center. Angle BAC would be this guy right here. Angle BAC is here, A is in the center, so that means A is in the middle when we name it. We could also call this angle CAB. So we could go backwards as long as A stays in the middle. An arc on a circle is just a part of the circumference. So in this particular case, they're referring to arc BC. Arc BC, remember, I need to travel when talking about arcs BC. I'm going to travel with in the circle, and I'm going to go directly from one letter to the next. So when we name an arc, we can name it with 2 or 3 letters, and we go in order of those letters. So if I wanted to name this other arc BDC, I would have to start at point B, go all the way around through D before I get to C. So this would be arc BDC over here in the red. Notice I used 3 letters because I had to determine that I needed to trace through point D in order to get to point C on the circle. So 2 different arcs here. In this particular case, because we have angle BAC has endpoints located here at B and here at C. So the arc between those endpoints is called the intercepted arc. That intercepted arc is going to be a common term that you hear as we go through this topic, and it is created simply by endpoints of an angle within the circle. Last but not least, arc measure and angle measure are both measured in degrees. We're going to stick with degrees today, and obviously those are all part of 360 degrees, which is within a whole circle. We're going to stick with degrees today for the sake of measuring arcs and angles. We will get into other units later. So let's go ahead and talk about arcs, a different sort of classification, kind of like what we had. A minor arc is less than 180 degrees and typically is used by 2 letters. You can use more than 2. As long as the arc is less than 180 degrees. So you can use more than 2 letters to name that as long as your arc is less than 180 degrees, okay? You will never top 3, so you could use 2 letters or 3 letters. Your major arc has to be more than 180 degrees and typically is going to be denoted or notated by 3 letters. Does anybody know what a semicircle could be? Think to yourself for a second. A semicircle. Let's say I went ahead and made a line or a diameter. Let's just go ahead and call this point G. A semicircle is literally half of a circle. So our semicircle here could be arc BCG, or we could go ahead and call it arc BDG. Your semicircle is half of a circle, and both of those would measure to be 180 degrees. Next, we have something called a central angle. So your central angle is kind of what it sounds like. It's an angle whose vertex is at the center. We're going to focus just on these 2 types of angles today. This is the first. And basically it just says that we have 2 sides of our angle. The center's at the vertex. The vertex is at the center of the circle. And then obviously it makes an arc on the circumference of the circle. This arc measure that I highlighted up here in red, let's go ahead and call this arc AB. All right. This arc measure is going to be the same measure as the central angle. So if this central angle here, let's say was 80 degrees, that would mean that this arc measure is also 80 degrees. So that's the measurement the relationship between the central angle and the arc measure. Notice that the sum of the measures of central angles should add up to 360, and the sum of the arcs would also add up to 360 if we went all the way around the circle. Let's go ahead and try a couple of examples. Take a moment, pause the video, write these down, and I'm going to go through them for you. So they asked us to find the value of x and the measure of each angle. So if I tackled number 1, I'm looking at the fact that I have an angle here of 105. I have a smaller angle here, x. I have another angle here, 2x, and then a 4th angle here of 120. Notice all of these angles make the whole circle. So I should think to myself, well, I know all of the angles that go around the center of the circle should add up to 360. So if I was to solve this problem, I could think to myself that 120 plus the 105 plus 2x plus x should equal 360 degrees. If you subtract the 120 and the 105, you're going to get 2x plus x, or 3x. My apologies. We're going to go ahead and subtract the 120 and the 105. Just so I'm going to combine two steps here in one. Okay. So if I subtract those from both sides, and then I had my two like terms, I get 2x plus x is 3x. 360 minus the 120 and minus the 105, I'm going to set that equal then to 135. Solving, I would go ahead and divide by 3. So I'm going to get x equals 45 degrees. So our question said find the value of x and the measure of the angles. So this angle here would happen to be 90 degrees, as well as this arc, even though they didn't ask us for that. And this angle in here would be 45 degrees. This arc would also be 45 degrees. Moving on to the second one, if you look, you might be thinking, I don't know what this is, so I can't approach it the same way I did the last one and add them all up to 360. You might think that this question mark here that I've placed could be equal to 4x, but those angles aren't quite vertical. If they were, you could say they're equal. So I challenge you to look at other parts of the circle. We just went over the fact that this is a diameter because it's going through a center, straight line, touching the circle twice. And we know that this would be a semicircle. We know a semicircle adds up to 180. So we could use that to go ahead and solve for x and then substitute. So we could say 2x plus x plus 5 plus 4x all adds up to 180 degrees. If we added those up and combine our like terms, we get 7x plus 5 equals 180 degrees. Subtracting our 5, 7x equals 175. And then if you divide by 7, you get x equals 25. Once we have our x value, we can go ahead and substitute our values in. So over here, and for our 6x, we would just do 6 times 25, which is 150. Right here, 2x would be 2 times 25, which would be 50 degrees. X plus 5, or 25 plus 5, this would be 30 degrees. 4 times 25, this would be 100 degrees. And if they asked us to find this missing angle measure over here, remember, it's the missing one from a circle. So we could take our 360 degrees and subtract all of these other measures. Well, 150 and 50 is 200. 130 would be 130. Just trying to condense here so we don't run out of room. And then if you subtract those, we get that this angle is 30 degrees. Let's go ahead and talk about another type of angle. It's an inscribed angle. Inscribed sounds like inside, and that's kind of what it is. It's an angle that's inside the circle. Its vertex actually lies on the circle. So vertex on the circle. So an inscribed angle has a vertex on the circle, but it still opens up and has endpoints that are also on the circle. This would still be our intercepted arc right here. Notice slightly different. It's actually a little bit smaller of an angle than the central angle. Central angles can be a little bit bigger. But here's the relationship. An inscribed angle is half of the measure of its intercepted arc. So earlier we said that this angle equals this arc. This time it's half. So if this angle was y, this measure for this arc would be 2y. Or like we have over here, 50 is the inscribed angle, multiplied by 2, and you get 100. So let's go ahead and use this. If you want to go ahead and pause your video, copy these down, and see if you can come up with it. We're finding the value of the missing angle of our arc measure. If you're solving, we know that this 76 actually represents this arc right here. So the 76 represents this arc. These are actually A and B endpoints of this inscribed angle. So that must mean, let's go ahead and call this X, that X would be equal to 76 divided by 2. It's an inscribed angle, we cut it in half, so that means that X is actually equal to 38 degrees, or the measure of angle ADB is equal to 38 degrees. For the next one, we can go ahead and look. We've got this 45 degrees is this angle, and it's actually at the vertex of angle CBD. So this angle CBD opens up to endpoints C and D, so that would mean that this arc DC, or the measure of arc DC, pay attention to my notation, this is proper, little m is measure of, and in the arc you put the two letters D directly to C, notice I didn't put DAC or DBC, would be equal to the inscribed angle multiplied by 2. So this arc would be 90 degrees. Looking over here at the second one, we might be thinking, okay, well, I need to find this angle. Well, it would be really helpful if I knew what the intercepted arc was. Here's the endpoint and the other endpoint of this angle. So this intercepted arc would be really, really helpful also. Well, I'm also given that this angle over here, this arc measure over here is 179, and this arc measure represents this whole piece of the circle. And then I have this 113. This 113 is representing this arc of the circle. Well, I know that 113 plus the 179 plus this missing arc make the full circle, so those should add up to 360. So let's go ahead, 360 minus the 113 minus the 179. If I subtract those, I get 68 degrees. So that means that this question mark, or this intercepted arc, is 68. Well, now I can find my inscribed angle would just be half of half of 68. So our question mark, or our angle here, would be 68 divided by 2, so we should get 34 degrees. You might be able to put this together by now, but if we have an inscribed angle, let's say angle HAL, and we have central angle HOL, they actually have a relationship if they open up and have the same endpoints. So if you look here, point H and point L are the endpoints of both angles. Angle HOL is the central angle. Angle HAL is the inscribed angle. But they have the same endpoints and they share the same, remember what this is called out here? Intercepted arc. So this intercepted arc is going to have some measure. We know that the central angle will have the same measure. And we know that an inscribed measure, or an inscribed angle measure, is just half of the intercepted arc. So it's going to be half of the central angle also. So they're saying here, if central angle HOL actually equals 98 degrees, that means that this is 98 degrees, and that would mean that angle HAL would be 98 degrees divided by 2, which gives you 49 degrees. Using that idea, we can work through a couple of other, shortcuts, if you will, to solving for inscribed angles, central angles, that kind of stuff. Our first big idea says that if we have two inscribed angles with the same endpoints, so our blue angle reaches up here and here, this is an endpoint, this is an endpoint, our red angle also reaches up to this endpoint and this endpoint, meaning that they share the same intersected arc. Well, if they share the same intercepted arc, that means that both of these angles will be half of that intercepted arc, so they must be congruent. Another thing to look for within our circles, and this is something to look for as you guys get like more complex diagrams to work with, is that if you have a central angle that opens up to an endpoint and then another endpoint that actually make a semicircle, that means that the angle then has to be half of 180 degrees, so this would be a 90-degree angle. So if you have an angle who opens up to endpoints that are actually the diameter of the circle, then that angle has to be 90 degrees. Last but not least, big idea number 3, if you have a quadrilateral, meaning a four-sided shape, inscribed, ooh, we used that word earlier, but that means inside of a circle, meaning that all 4 points of the quadrilateral are touching the circle, then that means it's inscribed. That means we have relationships between opposite angles. Opposite angles are now supplementary. So supplementary means 180. So if this is 100 here, that would mean that this angle has to be 80. And we would know that whatever angle x plus whatever angle y is also equals 180. Let's go ahead and use these ideas to try some additional practice. I'm going to do a couple of these, and then I'm going to have you guys try a couple on your own. So for example number 1, go ahead and pause. You can copy these down and do these problems with me. We have a four-sided figure inside of our circle, and this would be a quadrilateral inscribed within a circle because all 4 points are touching the circle. We know that this angle is 3x minus 32, and this angle is 3x plus 2. We don't know what the other angles are. We don't know any of the arc measures, but we just talked about big idea 3 that says that the opposite angles, 3x plus 2 and 3x minus 32, are going to be supplementary to each other, which means that they add up to 180. So if we combine our like terms, 3x and 3x is 6x. 2 and negative 32 becomes negative 30 equals 180. A lot of us are making mistakes here, but remember, we have to do the opposite sign. It's an easy error to make. We would actually add the 30. So we'd have 6x equals 210, divide by 6, and you're going to get that x equals 35. Now they just said find the value of the variables. If we needed to plug this in or substitute to find the angles, we could. For number 2, if we look at our opposite angles, we know that y plus 71 should equal 180. Well, we can easily now solve for y just by subtracting the 71. So we know that y is going to equal 109. And we know that our other opposite angles here, x plus 80, are also supplementary. So subtract our 80. Both sides, we know x is going to equal 100. So that's using those big ideas, big idea number 3 specifically, and we can go ahead and apply that further. So go ahead and take a minute. These are our last additional practice problems. I want you to pause the video and copy these down, and then go ahead and try these on your own. This would be a good test to see if you are understanding what we went over today and if you could then tackle the homework. So go ahead and pause and give it a whirl. Let's check our answers. I'm going to go ahead and walk you through them. So first of all, we're finding x for number 1. So we have this 50 degrees, which represents our central angle, or angle ACD. We have to use what we know about the central angle. Well, the first thing we talked about is that the central angle actually equals the arc measure of its intercepted arc. So this arc is 50 degrees. X is actually representing the inscribed angle. So we know that this inscribed angle also opens up to points A and D just like the central angle did. So x must be half of the central angle or half of the intercepted arc. So x must be equal to 25 degrees. If you got that one right, raise your hand, pat yourself on the back. Woo woo. All right, moving forward. Let's look here at number 2. We got a lot going on. We need to find x. X is an inscribed angle, and it opens up 2 points B and D. So in order to find x, it would be really, really helpful to either know this arc measure, or we know that x and its opposite angle, we could call it y, should be supplementary. So let's go ahead. I'll go ahead and find x the first way. So if the first way I mentioned. So if we go ahead and we ignore this opposite angle, we could go ahead and find x by figuring out what this missing arc would be. We could figure out this missing arc by taking 360 and subtracting the 54, subtracting the 115, subtracting the 86. And if we did that, we would go ahead and subtract all of those arcs, meaning that all of those adjacent arcs are going to add up to the sum of the degrees of a circle. So if you subtract those, you get 360 minus 86 minus 115 and minus the 54, you get 105. So that means this arc is 105. We know x should equal half of the measure of this whole arc, the measure of arc BAD. So x should equal 54 plus the 105, and then cut that whole thing in half. So if you add the 54 and the 105, and then you cut it in half, you get 79.5. The other way to consider this problem, and there's going to be a lot of different ways you guys can solve these problems, which is kind of cool. If we consider this angle, we know that this angle opens up to B and D going this way. So BCD, we could figure out what y was using the same method and then subtract it from 180 to get x. All right, number 3. Let's take a look at number 3. The first thing I would say is, I have a 4-sided figure inside the circle. I know that opposite angles are supplementary. So in my head, I'm saying that x plus y equals 180. Can't solve anything there because I don't know those. But I'm also saying 93 plus z equals 180. Oh, now I have an easy way to solve for one of my variables. So I can say that z is equal to 180 minus the 93. So if you subtract those, you get z equals 87. I can go ahead and substitute this in there. I still know x and y add up to 180. So now let's go ahead and see if I can use my arc measures to determine another angle. Well, 58 is this arc. 106 is this arc. Ooh, these endpoints are actually the endpoints of angle x. So angle x is an inscribed angle, so I know that x must be half of the sum of the two arcs that it opens up to, 58 plus the 106. So if you add the 58 and the 106, and then you end up dividing that by 2, you should get angle x, which is 82, or the measure of x, I should say. Finally, for y, we know that x plus y was equal to 180. We already said that up here. So we know that y would equal 180 minus 82, so y would be 98. I hope you got all of those correct, and I hope you're feeling comfortable with this material. If you have some questions, obviously message me on Portal or Remind or something like that, and we can work out some issues if you have any. Go ahead. Your homework today is actually a worksheet. It's attached within the resources on the Teams assignment, so you can go ahead and open that attachment. You can either copy the problems into your notebook and solve them, or you can modify the worksheet. If you modify the worksheet digitally, you must show all work. Some of you I know are using a stylus and writing right on your computer screen, which is great. When you're done, upload notes and homework to the assignment before you turn it in. Have a great day.